Hello. Yeah. Today we will see microservice core concept. Right. So, microservice core concept. What we know about microservice is that is before microservice we have monolithic application, right? So to overcome the drawback of monolithic application, we are forwarding towards microservice based application, right? So in monolithic application, what happened? Mm, we have only one application, and in that application all the services and all the features are included in a single jar file, right? But in microservice based application, uh, it's like different services, and it's in modular approach. Means every service needs to be deployed uh, independently, or each service having different database, and each services are independent, and it should be in a modular form. So these are the some benefits of microservice. So we will see one by one what microservice is really. So in software engineering, what happened, uh, we have service oriented application also, and before that we have monolithic application. But microservice based application is loosely coupled and as well as fine grained services, means communicating through the lightweight protocol. So in microservice based application we are using HTTP protocol for intercommunication purpose, right? So to adapt microservice in real time project, so it should have some rules and regulation we need to follow. So have it is having some attributes also. So likewise, we have total 9 attributes, and we need to learn one by one. Keep watching this video up to end, because we will cover each and every point in details of the microservice core concept. So it is having 9 attributes of microservice. Okay, so we will see one by one. First attribute is componentization via service. Componentization via services. What is this? Componentization via services means you should try, means you have to try definitely to make different features as a component, right? If we are having one big application like monolithic application, so differentiate that application in a component and make that component as a service, right? So try as much as possible to make your component as a service. So make your component as a service, right? This is componentization by service. And in that we have modularity of your system should be done using the process component. Means your system should be in modular form. So should be it should be modular, right? And rather than process component implemented as libraries, means rather than implementing library or service should be, means our component should be a service, right? uh, by applying this, we will get advantage like the ease of deployment and maintenance of the system. uh, this is one of the advantage, as well as it should be valuable for the service. right? So this is componentization wise service, and in that, if you are following modular approach, so it enables the flexibility, scalability, and ease of maintenance, right? So it should provide us what flexibility, PILTY, flexibility, scalability, and ease of maintenance. Ease of maintenance, right? Okay. So this is componentization via service. Second one is organized around business capabilities. Organized around business capabilities, right? Second one is organized around business capabilities. Now, what is this? So, this forces the team, means in project we have a development team, testing team, deployment team, and after that we have senior team member, like project manager and team leader, senior developer, right? So, microservices forces the team to think long and hard about the boundaries of the service. Means how much we are scaling the service. We should know, right? So we need to think on that. And we cannot say, let's start with a small API and see where it goes. Because it might be very longer, right? So that communication between other services should be simple. And we cannot change the API wherever we want, right? Since other service will become incompatible. If we are changing the API of one service and it should not incompatible with other, then it might get harmful, or it should be impactful for our application, right? So with well boundaries, we make a system more modular. So what we can write here, it should have boundaries. Should have boundaries. And then uh, we can say that we make a system more modular, the service more independent of other service and ease of maintenance, right? So organize the service based on the domain, not on the size. It is one of the important aspects of organized around the business capabilities. Means uh, while working on project, our senior team member uh, or architect level people, they are design the system. So that time what happened? They are mainly focusing on the domain knowledge or the functional knowledge. They are not thinking on what is the size of the API, uh, what will be the code size, because we need to just focus on the domain, not on the size. So here we can write focus on domain, not on size. Okay. So microservice handles one set of related function with a little or no cross-domain operation, right? And operations aren't defined on the data object or the business object instead of the domain as well. So this is organized around the business capabilities, right? Then third one is decentralized governance. Decentralized governance. What is this? Decentralized governance, basically what happened uh, at the time of developing the application, right? So we are not forcing the developer like you should use only this technology, you need to follow this protocol only. So our system is not a centralized governance. Means any rules and guidelines is not there to make the development, right? It's depend upon their technology and tools, whatever the particular company is using, right? So it lets the team to use the technology best suited for the service need. If we can say that use technology technology which is best suited for your service. We don't need to follow any guidelines of the government. Means it's totally decentralized. And no need of service handling documents with slow and incompatible relational database. Right? And we no need to follow any legacy technology also. If you want to, like, we can say that right now, Java version is 22. 22 version is going on, right? So in version 22, we can make our project by using Java version 22, right? We no need to follow any legacy pattern like they don't force us to use only Java 8. If we are using this, our system becomes slow. So microservices allows us to follow the decentralized governance, right? By using this, what happened? We need means we can use lightweight as well as faster. Uh, what we can say to make a service as a faster, we can use latest technology, and team can use the best tool for the task and makes team satisfied. So as a result, the other service and the end users too, right? So this is decentralized governance. Fourth attributes of microservices is decentralized data management. Decentralized data management. Okay. Now decentralized data management is basically, I have one diagram here. This one is here you can see we have monolithic application and we have microservice based application. Now here you can see that in monolithic application we have our project in a compact form, right? And in compact form we can communicate with a single database only. Means our application needs only single database. So it should be very complex and not easy to read, not clean up code is there, right? So this is the advantages. This is basically its disadvantages by using monolithic application. But in microservice, it makes it very simple for us because each service having its own database. So every services communicate with their own particular database, right? So it makes very simple to communication of the database. Means it makes the service more autonomous. Makes service. First we'll write here what using a separate database for each service. Using a separate database for each service. Second one is it makes the service more autonomous. It makes the service more autonomous. Okay, right. That's why it's less dependent on the other external mechanism. So this is decentralized data management. As well as each microservice has its own database we already saw. or data store, and so that it's allow the team to choose the most suitable solution for the service requirement. If someone want to use NoSQL database, that time they can use MongoDB. If someone want to use RDBMS, like relational database, they can use Oracle, they can use MySQL. Is each service having its different vendors database. So it's one of the important aspects of attributes of microservice, like decentralized data management. Then next we will have infrastructure automation. Fifth one is infrastructure automation. Okay. Now infrastructure automation, this one is fifth, right? Now infrastructure automation is basically fifth one is infrastructure automation. So infrastructure automation is means if you are working on any framework like Spring Boot application, that time we'll get one jar after running the application. Okay. So what we need to do, we need to take this jar and we can manually deploy this jar in any of the cloud platform, or we can deploy this jar in our internal server. So basically it's too slow and too long process. For that microservice, not force, but microservice suggest us to we have infrastructure automation. Now what is infrastructure automation? Basically it's automation for deployment, right? Automation for scaling, monitoring, and recovery of the application. And it enable the rapid and reliable delivery of the software at scale. Means we need to set up one CI/CD pipeline for deployment process, like continuous integration and continuous deployment. We need to use different tools for deployment, like containerization. It's Docker. Need to create container by using Docker. After that, need to be orchestration platform like Kubernetes, right? And we need to set up one Jenkins pipeline to deploy our applications smoothly. So infrastructure automation is one of the important, is very important aspects while deploying the application in a production environment. We can say simply we can say. So what we can write here, we can write deployment SHOU should be easy using tools such as Docker and K8s means Kubernetes. Okay. Then we have fifth attribute is there. Fifth one is over. Sixth is smart endpoints and dumb pipe. Okay. Smart endpoints. Smart endpoints. Everyone should know we have two service, or we can say we have uh, two application. Like one application is Flipkart and other one is payment integration. Now, payment service provider should give their code. So, one Flipkart application need to consume the API of payment service provider, right? So, this communication is how this communication happens. So, we have protocols like API. We need to call this by using API. So, API comes with two types of API. REST API is there and SOAP API is there. But most cases, REST API is useful. It is representational state transfer. So what does it means. So basically all communication between individual service in a microservice architecture is over the HTTP using REST-based service in most of the scenario. This allows for the use of any coding language or framework that supports RESTful web service. Here, actually, I don't have this diagram. Okay, so your endpoint should be smart. So we need to follow REST standard for that. What is your endpoint? How versioning should be there? What is the protocol? Right? What should be your header? So teams can develop microservice in any technology. However, cross communication should always be in REST over the HTTP, right? So they all communicate in a common way, despite being the developed in any manner. For that, what happened? Teamwork is faster as they are in the technology they are good at. So in pure microservice, any service can talk to any other microservice by using REST standard only. Just keep in mind. Okay. So what is we have API proxies there. Okay. So how this API layer is? Now API layer is a common component of microservice architecture. API layer should not transform or execute logic. Your API layer means we can say that it's standardized proxy interface that will expose whatever service endpoints and API operations. Okay, so this is sixth. Now our seventh attribute is designed for failure. So everyone is perfect in the world is not like that, right? While designing your microservice, it might get failure while working on the services. So how to handle failure scenario while designing your microservice application? This is one of the challenges in microservice. For that also, microservice gives some principles. So how to uh, play around with that principle? Now, microservices are designed to handle failures gracefully with a mechanism such as redundancy, means redundant data is there, or circuit breaker is there, means fallback mechanism, retry mechanism is there. If one service is communicate with other service, that time if one service fails down, now one service can't communicate with another service. For that, we need to create instance of the other service, right? So that communication happens. Means circuit breaker is one of the important aspect of that, right? Resilience, focused approach ensures that the system remains responsive and available. If one service goes down, our system should be connected with each other. So these types of failure scenario we need to handle while designing the microservice. Means unexpected failure should be there. Okay. So these are the attributes of microservice. Thank you.